So I think by now you're familiar with function notation. I have mentioned it before, but let's go over it again. In an equation such as y equals 3x plus 8, y can be replaced by f of x. The equation becomes f of x equals 3x plus 8. This way of writing, although you won't see it now using f of x, is, well, you might see it. It has some uses in grade 11. It really comes in handy for finding derivatives and when you take calculus. So it comes in much handier later rather than now. So you might, if you could just trust me, you might be thinking, well, why not just use y? Well, f of x has, f at x or f of x has some, that notation is very useful for higher level math. Another reason is that you can give it other names. So if you're dealing with three functions, you could call it g of x, h of x. You can give it any letter you want. Do you mind closing the door? Thank you. Thank you. Okay, if f at x equals x squared plus 3x minus 7, find f at 4. So notice the 4 is where the x is, right? 4 is where the x is here. So whenever you see an x value, you're replacing it with a 4. So let's just substitute 4 in for x. So that's 4 squared plus 3 times 4 minus 7. And that will be 16 plus 12 minus 7. And that's 28 minus 7 is 21. Okay, let's try f at a plus 1. Okay, so again, notice where the x is, they put an a plus 1, and that again means wherever there's an x value, sub in a plus 1. So we're going to go f at a plus 1 is equal to a plus 1 squared plus 3 times a plus 1 minus 7. So this is equal to a squared plus 2a plus 1. Don't forget I'm foiling there. Plus 3a plus 3 minus 7. So collecting like terms, this is going to be a squared plus 5a plus 4 minus 7 is minus 3. So f at a plus 1 equals this. Okay, so part C is different. It's not asking for f of 3, right? What it's saying is they're telling you your y value equals 3. So they're saying find x if f of x equals 3 or if y equals 3. That's what they're really saying, right? So now wherever there's a f at x, we sub in 3. Uh-oh, wrong equation. Better look down here. Equals x squared plus 3x minus 7. So we have to set one side to 0. That's going to be x squared plus 3x minus 10. So that's easy to factor. So we'll factor 0 equals x plus 5 times x minus 2. So x equals negative 5 or x equals 2. So be very careful. This is a common mistake. What people will do, they'll see an expression like this and they'll jump in and just substitute x for 3, but that's not what it's asking. We don't know x, we have to find it. They say find x if f at x equals 3. So just be careful about that on a test. Uh-oh. Now we have two functions, right? F of x equals 4x minus 5. G of x equals x squared plus 2x. Find f of g of negative 5. Okay, so what this means now is we have to work with we work what's in the innermost part of the brackets. We're going to come in here and work with this first, right? We're going to find g of negative 5, so we'll do that first. G of negative 5 is equal to, so I go to my g function, and wherever there's an x, I sub in negative 5. So this is going to be negative 5 squared plus 2 times negative 5, and that is equal to 25 minus 10, and that equals 15. Now, we're not quite finished yet. Now we have to find f of 15. So unfortunately this is a little bit tight, but f of 15 now is going to be, do you see, we know g of negative 5 equals 15, so now we're going to find f of 15. So f of 15 is equal to 4 times 15 is 60 minus 5, so that equals 55. So if you understand this, the rest of these are easy. So notice you go to the innermost part of the, you got to go inside, the deepest side, okay? Deep, deep, deep. So the deepest one is f of a, so we'll find f of a. F of a is equal to 4a minus 5. Now it gets nasty because we're going to have to square 4a minus 5. But that's okay, it's doable, right? So g of 4a minus 5 is equal to 4a minus 5 squared plus 2 times 4a minus 5. So unfortunately, I apologize, this is very tight. We'll just try to put it in there. So this is going to be 8a squared, no, 4a times 4a is 16a squared minus 20a plus 2, 5. Still not enough space. And then this is going to be plus 8a minus 10. So now we'll just collect like terms. And this is going to be 16a squared minus 40a plus 8a is minus 32a. And plus 25 minus 10 is plus 15. Can I explain anything better? And no, it just says it's not asking us to factor, it's not asking us to solve, it's just saying find g at f of a. Yeah. Okay, so let's do this guy. G of a, I'm so used to writing x, I keep on writing it. G of a equals a squared plus 2a, right? Because you start inside the brackets. You do that first. And then f of a squared plus 2a is equal to 4 times a squared plus 2a minus 5. And that's going to be 4a squared plus 8a minus 5. I just want to make sure I don't make any boo-boos. So same idea. Am I insulting your intelligence? I'll let you do this one by yourself, but the f of g at 2 is equal to 27, and I'll let you do that one. Uh-oh. This one we have to do this substitution 3 times. They want g of -2, then they want f of g at -2, and finally g of f of g at -2. Okay, so let's do that one. G of -2 is equal to -2 squared plus 2 times -2, and that's 4. Oh, that equals 0. That's nice. Then we're going to go to the next one and find f of 0 equals 4 times 0 minus 5 equals -5. And then we're going to find g of -5 is going to be -5 squared plus 2 times -5. And that's 25 minus 10 equals 15. Good. Okay, show the following set of data in a mapping diagram. Alrighty, so the mapping diagram, remember the first oval represents the domain and the second oval represents the range. So this is domain and this is range. So we'll just put our domain in here, -5, -3, -1, 1. And then it's going to be 1, 2, 3, and 2's already there, right? So we have -5 maps onto 1, -3 maps onto 2, -1 maps onto 3, and 1 maps on to 2. So tell me, is this a function? Does every x value have one y value? Here, I want to show you. Let's just graph these points and then you might change your mind. Let's see. It starts with -5, -3, -2, oh, -5, -3, -4. Okay, just like that. 1, 2, 3. My pen is dying. I'll use a red one, I guess. This is x, this is y. So -5, oh, we better do our y. What's the biggest y value we have here? 1, 2, 3. Okay, so -5, 1 is about there. -3, 2 is about there. -1, 3 is there. And 1, 2 is there. Does it pass the vertical line test? Yeah. So this is a function. It's not asked. The question doesn't ask determine if this is a function. I'm just reviewing yesterday's work. If you have a diagram, a mapping diagram, how can you determine if this is a function or not? How would a mapping diagram that's showing that it's not a function look like? You'd have 2 arrows coming out, right, out of x. But all of these only have 1 arrow. So this is a function. Okay, it is a function. Okay, let's just flip over. Here it says write ordered pairs associated with the following mapping diagram? Okay, so let's write them. We have -1 maps on to -3, right? 1 maps on to -3. 1 also maps on to 0. Oh, notice 1 has 2 y values, so this is not a function, right? 3 maps on to 2. And 5 maps on to 2. Oh. Okay, another way some textbooks will display a function is this mapping notation, which I'm just gonna show you. You won't be tested on this, but just to make you aware, sometimes textbooks display it like that, but I wouldn't worry about it too much. I don't think you will see that at York Mills in any time soon. So, okay. Can I explain anything better, anything at all?